Welcome to the Purpose Nation podcast, inspiring conversations with Christians in science, technology, and industries of the future. For more information or to make a tax-deductible contribution, visit purposenation.org.
This is Brad Cooper with Purpose Nation, and today we are really excited to be joined by biologist, Professor Daniel Kuebler. Professor Kuebler, welcome to Purpose Nation.
Thanks, Brad. Thanks for having me. Delighted to talk to you today.
Welcome, and we're super excited to have Professor Kuebler with us. He's our first biologist on the podcast, which is great. He's also our first guest who is a head coach of the cross-country running team, I think. Is that right, Professor Kuebler?
Yes, I am. So,
how is the team looking this year?
We have a pretty solid team this year. I'm really excited about it. It's nice because I teach a lot of some courses in exercise physiology, so there's an overlap between what I teach and my coaching. So and do a good job of recruiting biology majors to the team as well. So.
Oh, that's awesome! Yeah, you get the double whammy there. So runners and biologists, which is a great combination. That's awesome. Well, I was on the cross country team in high school, and I love running. But these days I pretty much get exhausted just chasing my kids up the stairs, I think. So
that's where I am. Every year I get a little slower, so the team gets a little further in front of me, but that's good.
I think you probably do a good number of kilometers out there on the road. So I respect that a lot, and that's awesome. And it's great that it also ties into your background, which I'd like to just kind of give a quick background anyway. It's kind of hard because you've got a lot going on there, but Professor Kuebler is a professor of biology and chair of the biology department at Franciscan University of Steubenville, which is a Catholic university. Seems like a great school. He teaches evolutionary biology, cell biology, human physiology, and as he just touched on there, his research revolves around a couple of areas, regenerative medicine and knee osteoarthritis, which I didn't realize it affects this many people, but 27 million adults in the U.S. are affected by this. And so he can...
It's relatively common, yeah.
I had no idea. Yeah. He conducts research also on seizure disorders faced by millions of people as well, including people with epilepsy. And so he's written important papers on these subjects. He's also the co-author of a book called The Evolution Controversy, a survey of competing theories. It's kind of a book that looks at the different theories of evolutionary thought, and it's a great book, and we'll definitely have a link to that on the podcast. And he's been published many times in a lot of popular articles on science and the Catholic and Christian faith. And he received his PhD in molecular and cell biology from the University of California at Berkeley and earned a master's of science in cell and molecular biology from the Catholic University of America. And he also holds a bachelor's degree in English from the Catholic University of America. So great stuff. Always excited, especially to hear, and have guests who are, some of the research projects at least are, focused on curing diseases or, things that really can have an actual kind of hands-on impact. Sometimes when we talk to astronomers, it's kind of, for people, it's not as a close of a connection, and you talk about cosmology as to, hey, this actually is stuff that can help, people right now and today. So love talking about that, and it's kind of near and dear to our hearts at Purpose Nation. So Professor Kuebler, just if you could give us a little bit of an overview of a few of the kind of main high-level projects that you're involved with.
Yeah, so for years I had worked on looking at seizure disorders and looking at the effect that diet has on that. There's a lot of people that don't respond to current treatments, and there's a whole range of different sort of causes of epilepsy, many of which aren't really known. So treatments that work for certain people don't work for others, but we found certain diets seem to, particularly diets that are rich in fat, tend to reduce seizures. And we have an animal model. It's actually fruit flies that have seizures, and we can feed them different things and reduce their seizures, and then look and see, how that changes their behavior, what's going on in terms of their metabolites. So it's interesting sort of model to try to then, come up with ideas of ways to treat humans. But about 7 years ago, I was approached by some orthopedic doctors who were looking to develop better techniques to use adult stem cells to treat orthopedic injuries like osteoarthritis, tendinopathies, and so forth. And so what they do is we'll extract bone marrow, which is rich in certain types of adult stem cells, particularly ones that can give rise to cartilage cells. And they also will use platelets and adult stem cells from fat. So they had a bunch of different procedures, but the research on which one might work best for what type of injuries is really in its infancy. So I started working with a number of doctors doing sort of basic lab research to sort of grow these cells, how they respond to different combinations. So should you mix bone marrow with platelets, or should you mix bone marrow with fat? How do they behave? We can look and see how they behave in cell culture. That give us some clues about whether they're going to do well when you put them back into the body. One of the studies we're looking at right now is looking at how these cells just respond to the fluid that's in the knee. So if you take the synovial fluid out of a healthy knee and compare it to the synovial fluid for someone that has osteoarthritis, those are two really different environments. So if we're putting stem cells into this sort of nasty environment where you have this inflammation or osteoarthritis fluid, how well do the cells do, and what supplements do you have to give them to have the cells thrive in that environment to help possibly regenerate the tissue? It's a fascinating area because there's so little that's known. There's so many questions, and it's really an exploding area at the level of basic research to the level of applied research. There's just so many strains of thought out there, and trying to sort through it all is going to take decades, I think.
Yeah, it sounds like it. That's pretty amazing, and it sounds like you're part of being on the forefront of it there at Franciscan University of Steubenville. So if you can also just tell us real quick give your chance to give a plug for your college there, because this is great stuff and pretty cutting edge research that you're involved with at a university that's also happens to be a Catholic university. So tell us about the university as well and your department there.
Yeah, our department here at Franciscan, it is an undergraduate only department, but our goal with our students is to prepare them. Most of them are looking at allied health fields, medicine, physical therapy, doctor of physical therapy, physician assistant programs, and so forth, or going on to PhD programs. And really, the only way to fully teach science is actually to have students do it, and that's something that we really emphasize here. So all of our faculty have active research programs going. We have funding to support students during the year and during the summer. About 70% of our students end up doing research with faculty before they graduate, and that's really essential, I think, at an undergraduate level. So a lot of times you think you go to a small undergraduate school, you might not get many research opportunities, and that's not the case here. And you have to have those to really prepare students to go into graduate school or medical school. It's a really exciting time at our university because we've really made an effort to increase the research that goes on in the sciences. We have a lot of young faculty members that have come in with research programs that are excited to work with the students. And so you get student focus, you get to work with a faculty member, and you get to do some really interesting and sort of cutting edge research here at a relatively small universities.
That's great. Again, with the Catholic faith, so that you hear a lot about universities. Even Harvard had a Christian foundation, and so
right.
some schools will talk about a quote unquote sort of a Catholic tradition or a quote unquote Christian tradition. For your university, as I understand it, it's kind of more than just a tradition. You're sort of living out and acting out your faith as well.
Yeah, without a doubt. It is a truly Orthodox Catholic university. It's a commitment that our Father Scanlon, who was the president of the university back in the 70s, 80s, and 90s, sort of made. And it's really an organic thing because it's not something that we have to legislate from the top down. The students that we bring in are looking for an organic Catholic, authentic Catholic environment. And the faculty we bring in, they want to be here because of that authentic Catholic environment. And so you just have a very unique atmosphere on campus, and you really feel passionate about these students because you can see that they're driven to serve God, to serve Christ. And so you want to give them the best preparation because when they get out there into medical school and they get out there into grad school, they're going to have to, stand up for things that are going to be difficult. So you want to make sure that they are well prepared for that, spiritually, philosophically, theologically, but more important, you want to make sure they're prepared scientifically so they're going to be able to thrive when they get out there, and their peers are going to respect them and respect their opinions because they are well prepared. They know what they're talking about. So
right, that's great. Now, take us back a little bit into your own personal background. I see that it was an undergrad in English. So how did we get from English to biology? And sort of if you can walk us through, maybe I'm guessing there was some interest in science or biology back there in the childhood or teen or early college years, but sort of how did you come into the work that you're in now?
Really, as a child, as a teenager, I never really saw science as never really on my radar. There's no, I have some engineers in the family, but there's no basic scientist in the family. So it wasn't something that I was aware of really growing up. And I think, I went to college and I switched my major every semester for the first 2 years. And sort of, I was interested in a lot of different things. And about my junior year, I decided, maybe I'll go to med school. And so I started taking all the prerequisites to go to med school to apply, sort of settled on being an English major because I found that I love to write, I love to read, and the professors I had in the English department there at Catholic University were excellent. But what really sort of set me on my path was in my senior year there, I was asked to do research in the lab of a professor. He's now the chair at Catholic University, Venugala Rao. And that's when I really realized that science was about asking questions and exploring frontiers. I think growing up, you thought science was the class you just go in, you memorize all the answers, and boom, 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 you spit them back out. I never really had a great experience in the science class, in high school. And so when I had that experience in the lab where I'm like, so nobody knows the answer to this. And he said, no. So you've got to come up with, this is the experiment we're going to do to try to answer this. And then you had to think, well, will this experiment actually answer this? And you saw this you're at the forefront of knowledge, the puzzle solving, the thrill of discovery really captured me. And I was only working on bacteria viruses at the time, but I really was brought into that. And that really changed my view of science and my desire to go into science then.
That's amazing. Yeah. A couple of things you highlighted there is just something I've heard in other interviews too, is one, it seems like there's a professor or somebody who sort of connects the dots for you and making it kind of more interesting from a problem solving or puzzle solving, as you said. It's just great. And also, could you talk about your Catholic faith background?
Yeah, I was raised Catholic, and when I went off to college, went to a Catholic university, went to Catholic University of America in Washington D.C. So my faith was always part of my life, but it wasn't, I don't think, really my faith until I ended up going on to Cal Berkeley for my PhD. And I think when you're Catholic University and everybody's sort of Catholic, you sort of don't think about it, just sort of something you do. A lot of my friends, time to go to Mass on Sunday, and you weren't really challenged as much in your faith. And then being in Berkeley in that environment, I sort of thought, well, why am I Catholic? Why do I believe the things that I do? Because you were challenged on that. It was in that environment that I think started to take my faith seriously, and it actually became my faith. And I sort of wanted to understand, why did I believe or do the things that I did? Why would I want to live my life in this way? And that environment, when you're challenged, you either say, well, it's not worth it, or you sort of double down and really understand what it is that you're living for. And that was the way it happened with me. Being in an environment that wasn't necessarily amenable to my faith was what made my faith sort of develop into what it is now.
And what were some of the steps you took to sort of, I guess, gird up against some of the challenges that you saw? Were there particular books or philosophers, or was there resources or people that you sort of turned to that sort of provided you with some of the background on, okay, well here, because I'm guessing also you're at Berkeley, and then the field that you're in, those two combinations are not necessarily wide open for people to sort of insert God into the picture of evolution or creation. So, I mean, what were some of the things, if you can think back to that sort of supported you during that time?
Yeah, no, initially, there was a lot of conversations I had. I remember a couple postdocs in other labs that were interested in sort of some of these questions. They didn't fall on the same side of the issues necessarily that I did, but I did find a few people that were interested in talking about these things, about, what is the implication of the evolutionary understanding of the human person? Does that mean that there is no God? And we would discuss some of these things. And it was nice to have people that were open and interested in talking about these. And then the other thing was just finding a community of believers in Berkeley. And you no matter where you are, where you live, there you can find people and find friends that actually are trying to live out their faith. And you really need that, particularly in an environment like that. And I still have in contact with some of those people, even though it's been about 20 years now, I think, since I was out there. That's absolutely essential, I think, in that type of environment, is finding people, one, that are open to you and open to discussing these things, even if they don't agree with you, can really be beneficial. And then finding people that actually are like-minded in the faith. And
now, taking this back up to sort of present day, what are a few of the either discoveries that have been made recently, or kind of key issues that you're involved with that people in our audience may have heard of? What are both the promises of those, and then also on the flip side, what are some of the potential ethical concerns that we need to be aware of?
Yeah, I think what's really been sort of in the news recently, and one of the things that I think is something that's going to have wide-ranging implications if we pursue it as a society, is this genetic engineering of embryos, and sort of this CRISPR technology to be able to go into an embryo and switch out a gene that is defective and replace it with a healthy one. Because on the surface, again, it sounds like, hey, that sounds like a great thing. We're going to be able to cure diseases. But the reality is that this technique is going to change change, I think, if it ends up making it into the clinic, is going to change the way we really view humanity and the way we actually produce children. Because if, it's very difficult to legislate and determine where you draw the line between fixing a problem, fixing a disease, and where it becomes enhancement. People will argue and bicker about where that line is. I don't think there is an easy to define line. And once you start doing genetic manipulation of embryos and you start doing things that enhancement techniques, genetic enhancement where you're replacing, a normal copy gene with a more enhanced copy, for example, you start to get to the point where that is the way we expect our children to be. And that requires sort of IVF, in vitro fertilization. So the normal way of procreation is suddenly going to become sort of secondary. And I think, with the factors that might come into play with, insurance companies saying, well, if you're born with this gene, we're not going to insure you, or we expect, people with this genetic makeup not to exist, to be born. That changes, I think, the way that we now expect to procreate. And I don't think anybody really appreciates that, but that's something, we're right at the beginning of this stage, but if you look 30, 40 years down the road, that's exactly where we could end up. And I don't think people are aware of that as we start down this road. And I think, a lot of the CRISPR technology, the genetic manipulation here. So, if you have a lot of these early papers, they're showing this in practice in human embryos, you can remove a defective gene that causes this, rare blood disease, or, for example, in an embryo. In reality, what people are going to do is create a bunch of embryos, screen them, find the one that doesn't have that disease, and go ahead and implant that one. There's going to be few cases where I think you're going to actually need to do CRISPR to remove a defective gene. If you make 10 embryos, most of them aren't going to carry two disease genes on them, and you can screen for them and implant them. And so I don't think this CRISPR technology is really going to be useful so much for preventing disease, but it is going to be tempting to use it to genetically enhance traits. And we already see that with IVF, where, you have these gender disparities, that there's more boys than girls when you allow for IVF in certain countries. So you already see this mentality that you're going to select for the traits of your children, and you're going to select for traits that you deem beneficial. And I think, first of all, you have to do this all IVF, and that, as a Catholic, I have ethical issues with that, but partly because you start to make life a commodity that you can manipulate and buy and sell. Also, you see going down the road that it might be the case where you're expected to produce children through IVF because you're expected to ensure that they don't have certain genetic predispositions, they have other genetic enhancements, and there's going to be economic pressures towards that, I think, as well, when you look at insurance and medical care and so forth, particularly given the need to drive down the cost of medical care.
Right. And it seems like some of this is accelerated due to something you've mentioned it called CRISPR. Just as sort of in layman's terms, I don't know if you can sort of just tell us what it is and why, if it has sort of accelerated people's thinking on this. Even, as you said, even it may not even be that they're using it necessarily. It sounds like you're saying, well, forget CRISPR, just the fact that you can sort of determine, you can read the genes and see what defects they have and only select the embryos that don't have those. But what we see in the news is sort of the pushing forward of CRISPR. But what is that?
Yeah, CRISPR is a technology to much more effectively go in and to snip out a certain section of the DNA. And so you can target virtually using the CRISPR-Cas9 technology any sort of region, any gene. The CRISPR will go in and cut a piece out, and you can insert a different piece into that region. And the thing about CRISPR, a lot of times these technologies, when you do this, the older way to do it, it was difficult to get the exact region to be removed. You would often get very low successes, and you would also get, sometimes it would cut in the wrong spot, and you'd get these what are off-target sites where, you want to remove this piece, but you also removed another piece and so forth. So with CRISPR, you're less likely to get these off-target things where hey, I'm trying to hit region X, and instead I hit region Y. And it's much more specific and much more successful. Now, it's still at the point where you do get cases where, you get these off-target sites, and so there's still problems with it, but it's much more effective. It's also cost-effective. It's relatively cheap to do compared to the previous ways of doing sort of genetic engineering. So it's not only, it's faster, it's cheaper, and it's more accurate.
any kind of small lab now around the world can sort of start doing some of these things, which I guess is part of the issue, is that if it was something very expensive or difficult, you might have a better chance of sort of keeping an eye on it and as far as regulation goes and things like that. But it sounds like it's something like, pretty soon you can, it's almost like putting something in the microwave and heating it up. Is it?
Yeah, it's not technically that difficult for a trained biologist to do. And it's very useful in animal model systems to create specific mutations that you want to study. Hey, I want to see what happens when we do this to this gene. I want to see if this affects, how does it affect the mouse's immune system, for example. So it's a very, very useful research tool. It's like you said, it's very accessible to the research community. But then when you get to human embryos and you're modifying the human genome, you're getting to the point where you're right. It's going to be hard to monitor who's doing this and who isn't. And right now there are no sort of global regulations. There's no state regulations. There's no national regulations. I know the National Academy of Sciences came out with a position paper, and they were just saying, well, we need to do this thoughtfully and in stages, and we should proceed with research on this. And that there's sort of no oversight necessarily in terms of this research on a global scale or on a national scale. I mean, different universities might have different policies, and they have human subject review boards that would review anybody that's doing this type of research at a university, but there's no sort of ban on it or concern about where we might end up next. And I think that's typical of the scientific community, though. I think there's a mindset that science is here to serve us, and that we want to just go ahead and do what we can do. So if we're able to do this scientifically, we should go ahead and do it. And there's a lot of arguments, well, somebody's going to do it somewhere, so we might as well do it here and not let somebody else just run ahead and do it the wrong way. But I think that's sort of short-sighted.
Right.
Yeah, I was just saying it's really hard to regulate globally. You just know somebody's going to be doing this and move it into the clinic, I think, at some point.
Okay, yeah, it sounds like folks need to go out and watch that movie Gattaca with Ethan Hawke, and there's other sort of science fiction things that talk about the potential downfalls of stuff like this. And as you said, I think it's just also part of it is, and this happens in other technology fields as well, where the pace of change is almost accelerating, and it's hard enough for sort of lay people to keep up with these things and understand the terminology. So glad to have someone like you on sort of try to clear this up for us, Professor Kuebler, a little bit. Now, contrast that though with things that you are doing and that are kind of happening now, and how that can help people with knee osteoarthritis and things like that.
Yeah, I think the regenerative medicine field, although it's sort of in its infancy and it does get some bad press because there are doctors out there and clinics out there that do things that there's really no scientific basis for, and they're charging people and sort of taking advantage of people that are in sort of desperate situations medically. That the regenerative medicine is, I think, going to be in the next 10, 15 years sort of a new way of doing medicine. And I think it will change the way the medical field is structured. You have these adult stem cells throughout the entire body, and their job is mainly to repair damaged tissue, and to either by secreting growth factors to help tissue heal, or themselves to actually turn into new functioning cells. And so you have these there, and regenerative medicine is largely doing what's the best way to extract them and move them to help at the site of the injury. And normally your body, when you have injuries, stem cells from the bone marrow could be mobilized into the blood, and they might hone to the site of the injury. But the idea is if we could put more there, that's going to hopefully help with the healing process. But with any new technology, any new treatment, there's people that aren't going to respond to it. There's different techniques that you could use. Some are going to be better than others. There's different types of cells. There's different combinations. And so there's so much complexity here that answering those questions is going to take a lot of research and a lot of effort. But I think it's really, really exciting because it's looking at sort of the patient and the doctor now being at the center, rather than saying a pharmaceutical company being at the center of treatment.
Right. Great.
So, or, hey, do we need to get an artificial knee, or can we take my own stem cells, or, maybe even placental cells or placental tissue, and use that to help treat the knee, and then hold off you from having to have an artificial knee for 5-10 years, or hold off having to have, shoulder surgery for 5 to 10 years, and that's something that's at the level of, hey, these are my cells, my doctor, we do this, and can be cost effective compared to a surgical intervention, putting in an artificial joint. I think that's exciting because it makes things more personal in medicine, and it also, I think, can drive the cost down, and there are no ethical concerns. So other than people that are doing some of this stuff without, without good, science backing them up. But it's really an exciting field.
That's great. Yeah, that's very exciting, and looking forward to some of the things that are coming out of that research and what you're doing. Shifting gears a little bit and just talking about sort of the mixing of faith and science. And you talked about a little bit earlier, at Berkeley, and I know you've written a lot of articles about this in recent times, especially related to evolution. It's a word in itself that sort of sparks things one way or another with people. How do you, in these conversations and the articles you're writing and people you talk to, and especially students, who will be coming to your Catholic college there, how do you personally work to help people understand evolution and how that fits with Catholic or Christian faith?
Yeah, I think that's a great question, and I think I see students that struggle with this all the time, and adults that struggle with this all the time. As a Catholic university, one of the benefits we have is to look at some of the things that, particularly most recent Pope John Paul II, Pope Benedict have written about this, and I think what they've written is phenomenal, particularly what Pope Benedict has written, and he always looks at it as this, that the Catholic understanding or the Christian understanding of the creation, and particularly creation of humans, because that tends to be what people get concerned about the most, is where did we come from? An evolutionary understanding are looking at two aspects of the same question, and that evolution is looking at the physical origins of the human body, where when we talk about creation of a human person, you're looking at what is a human being in relation to God, and that there is something more than just this physical body that we are. And you look at Genesis and talks about God breathing life into man from the dirt. There is a physical element of us, right? This is dirt, there in the Genesis account.
Mm-hmm.
But there's this life of God breathed into us to create us, and the soul and the body there. That understanding of humans should make you think, well, wherever the physical body came from, and however the physical body evolved, there's more to human life, more to being human than just that. And I think just having that understanding can make people open to sort of looking at what does evolutionary theory have to say, because it's not necessarily threatening their faith as much. The problem, I think, is that there's often an assumption amongst the scientific community that man is just nothing more than a material being, and nothing more than just your physical makeup, and that is not a scientific position. That's a philosophical position. I always get my students to try to understand that. Like, if you're going to claim that man is just a material being, or if you're going to claim man has an immaterial soul, is sort of material, a being with an immaterial soul, both of those are philosophical claims, and science isn't going to be able to adjudicate those. So someone that's a materialist there and believes that evolution just shows that we're material beings is not making a scientific claim. And so you've got to understand that. And I think once people start to understand that, then they're more able to engage in those type of questions. And I think evolution is, to me, it's sort of resonant with sort of the way God works with us. God allows us. He's not a jealous creator. He lets humans, you and I, to co-create with him. We can produce children. But we don't do that on our own. And God allows us to work with him to create children. And I think the same way with the universe. God allows the universe to work with him to create. And I think that's a more, to me, a more profound and mysterious view of God and how he works with us. And it gives me a more profound and mysterious view of the universe. And that's what's at the heart of science, is a mystery. I'm a cell biologist, and for all that we know about a cell and how a cell works, and we can study it, and we can continue to study it, and there's new journals every year and thousands of papers on the cell. At the heart of the cell, what makes a cell different from a non-living thing? There's a mystery there that we haven't been able to penetrate, but that's not saying that we'll never be able to penetrate, but there's a mystery there we don't quite understand, and this is a level of awe and mystery in front of a very simple cell of how is it able to do all these amazing things, and that's the same way we look at God. We can understand God to some extent, but at the heart there's a mystery, and I think there's that resonance between science and our faith. That at the heart of reality is a mystery, but that doesn't mean we don't want to try to penetrate that mystery, and that's the way I like to approach science, and I think that resonates with my understanding of God.
That's good. And there must be some things too, though, that putting aside the internal in-house debates amongst Christians on the age of the universe, or or evolution, and what level is there evolution or not, does seem like, though, that I'm guessing it's seeing some of the complexity you see of even the smallest cell, that one can sort of, even if it's not a scientific sort of exploration, your faith exploration and seeing God's work. I mean, you must see some of that and just say, okay, well, it does seem like some of this is guided. But even if you can't scientifically prove it, it seems like the complexity from dirt, as you said, to the incredible complexity of a cell, there could be some guiding hand there.
Yeah, there is, and some people will argue that, hey, there must be a guiding hand sort of directing this. I take a slightly different view, but I think it's just as profound as that God has created a world that can, on its own, produce this. And that in itself requires a very specific world, a very specific universe. A universe that can create life is not a trivial thing. A universe that can allow for evolution to proceed is not a trivial thing, And so that's where I see sort of the hand of God, that we have this universe that can create these ordered structures and produce these things. This universe was designed to be this way, to create life and allow life to flourish and allow the origin of people like you and me that could know and love and serve him. And that's where I see sort of the hand of God. So you see, we have the very specific ordered universe that can allow for these types of things. And even though we don't know exactly how they may have occurred, if we understood natural way of how a first cell could have come from prebiotic chemistry, I think that would make me even more astonished at the universe God has created. That, wow, we live in a universe that actually can produce life. God has given us the universe and is sustaining at every moment a universe that can create life. That to me is more mind-boggling than God sort of directing it as it's happening,
Right. In biology, do you see, obviously you're at a Catholic university, so you're seeing a lot of students coming into the field because, just the fact that you're at a Catholic university. But in other universities, what's your sense of Christians entering either, going into like pre-med and becoming doctors, or, is that something we should be concerned about at all? And are some of these things potential roadblocks for people? And if so, what would your advice be? So if someone's listening and they're considering a career in biology or microbiology or some of these fields you've talked about, or medicine, what should they be, concerned about in terms of what's coming, or preparing themselves for? I shouldn't say be concerned, preparing themselves to sort of experience, and what do we do to sort of help them along?
Right. No, I think it's a great question as students enter these, what can they expect and what should they be prepared for? Particularly if you're going into research, you're going into a PhD program. I think that's where there's certain difficulties there versus difficulties going into medicine. I think you run up into more really ethical issues, practical ethical issues when you go into medicine, in terms of particularly euthanasia and abortion and things like that. But if you go into science and you're going into a PhD program in science, I think you end up in an environment where there is this sort of underlying assumption that religious beliefs are outdated, that science is going to be able to answer our questions, that there isn't anything that science can't figure out eventually. And so it can be sort of a draining environment to be in. That said, I think there are plenty of serious Christians in the sciences. I just don't think they're that vocal. Some of the more strident, materialist, atheistic voices there are in the sciences. And I think there's different societies that I think you can join to have like-minded colleagues. The American Scientific Affiliation is one group, it's a Christian group, and then the Society for Catholic Scientists, and there's student members there, and there's meetings, there's networking opportunities. And I think finding other people that take their faith seriously and are top-notch scientists or just starting their career is going to be helpful. And there are very eminent scientists like Francis Collins, who's, so I think, a role model for a lot of Christians who go into science and say, hey, there's somebody that's at the top of this field who is clearly well respected, but has not put his faith on the shelf somewhere, that he wears it on his sleeve, and it doesn't affect his ability to do top high quality science. And I think having people like that is important, and finding role models. And I think you can find those. Sometimes it takes a little bit of asking. If you're in a graduate program somewhere, there will be somebody on the faculty, and probably a few, that are good and committed Christians, and then just get to know them. They can be role models for you, and they can give you advice.
And hopefully we can have more Franciscan University grads out there, alumni that folks can go to, hopefully, here as
exactly
mentors.
That's our goal. Yeah,
That's great. The debates that you talked about, with atheists and things like that, and just again, what we're hearing in the popular press and across Catholic and other Christian leaders in these fields, it seems like it's important and sometimes put the internal Christian debates aside so that we can sort of coalesce around a common view. And as you said, some of these things are fast approaching. So we don't really have time to argue about some of these kind of more minor things. Yes, on key issues, right. Yes. But in terms of the pace of this, it seems like it's accelerating. And it seems like, frankly, there's some urgency that's needed.
Yeah, I think there is. And I think there is a lot more collaboration between particularly Catholics and Christians in terms of these issues because of the urgency about these things, these cloning, genetic manipulation, euthanasia, things like that I think that you're finding more willingness to work together. And I think there's a lot of outlets that scientists can voice their concerns in. Popular press, at churches, speaking at religious events. I think there needs to be more effort by scientists, Christian scientists, to be speaking to other Christians in public settings, to let them know what they're doing and what's going on, and to make these issues more visible. Because I think once you do that, you start to bump into other people who are in the same boat, who are also scientists, and you start to network better. And I think there are places that we could do a better job of just sort of getting that voice out there, because it's not often portrayed by the popular press that there are scientists that have grave concerns with genetic manipulation of human embryos, or there are scientists that have grave concerns about embryonic stem cell research and so forth, whatever the topic happens to be. But I think often we have to sort of go out and do it ourselves.
Mm-hmm. Amen to that, Professor Kuebler. Thank you so much for being one of those voices that are out there and willing to sort of put your faith out there too, and in relation to some of these issues, and writing many articles and contributing to adding that voice to many of these issues. So thank you so much for that, and thank you for your time today, Professor Kuebler. And so what is the next? I don't know when school starts there, but what's sort of the first few weeks of cross country? How many kilometers is the team logging every week?
Right now we just started classes yesterday. We were our first meet coming up this weekend, and right now they're probably getting close to 120. 130 kilometers.
Oh wow!
They are. I'm not.
Oh, okay. You've got your whistle there, and you're just blowing it and faster.
Faster.
I'm not quite to that level yet, but that's one of the reasons I'm excited to be looking at osteoarthritis, because I know one of my knees is going to need some of this in about 10 years. So maybe I can keep me running for a few more.
Yeah. Well, I'll be lucky to do 1 kilometer, I think, out there here soon. So 120, that sounds pretty daunting. So that's great. That's awesome. Again, thank you, Professor Kuebler, so much for your time today, and I just wish you blessings on you and your work.
Okay. Thank you, Brad. It's been a pleasure to talk to you. Thank you for your work with Purpose Nation.
Likewise. Thank you, Professor Kuebler, and we'll be talking to you soon. Take care.
Thank you for joining the Purpose Nation podcast. For more great interviews, resources, or to make your tax-deductible contribution to support our nonprofit ministry, please visit purposenation.org. This program is copyright Purpose Nation, Inc., a 501c3 nonprofit corporation. Welcome to the Purpose Nation podcast, inspiring conversations with Christians in science, technology, and industries of the future. For more information or to make a tax-deductible contribution, visit purposenation.org.
This is Brad Cooper with Purpose Nation, and today we are really excited to be joined by biologist, Professor Daniel Kuebler. Professor Kuebler, welcome to Purpose Nation.
Thanks, Brad. Thanks for having me. Delighted to talk to you today.
Welcome, and we're super excited to have Professor Kuebler with us. He's our first biologist on the podcast, which is great. He's also our first guest who is a head coach of the cross-country running team, I think. Is that right, Professor Kuebler?
Yes, I am. So,
how is the team looking this year?
We have a pretty solid team this year. I'm really excited about it. It's nice because I teach a lot of some courses in exercise physiology, so there's an overlap between what I teach and my coaching. So and do a good job of recruiting biology majors to the team as well. So.
Oh, that's awesome. Yeah, you get the double whammy there. So runners and biologists, which is a great combination. That's awesome. Well, I was on the cross country team in high school, and I love running. But these days I pretty much get exhausted just chasing my kids up the stairs, I think. So
there's actually fruit flies that have seizures, and we can feed them different things and reduce their seizures, and then look and see, how that changes their behavior, what's going on in terms of their metabolites. So it's interesting sort of model to try to then, come up with ideas of ways to treat humans. But about 7 years ago, I was approached by some orthopedic doctors who were looking to develop better techniques to use adult stem cells to treat orthopedic injuries like osteoarthritis, tendinopathies, and so forth. And so what they do is we'll extract bone marrow, which is rich in certain types of adult stem cells, particularly ones that can give rise to cartilage cells. And they also will use platelets and adult stem cells from fat. So they had a bunch of different procedures, but the research on which one might work best for what type of injuries is really in its infancy. So I started working with a number of doctors doing sort of basic lab research to sort of grow these cells, how they respond to different combinations. So should you mix, bone marrow with platelets, or should you mix bone marrow with fat? How do they behave? We can look and see how they behave in cell culture. That give us some clues about whether they're going to do well when you put them back into the body. One of the studies we're looking at right now is looking at how these cells just respond to
the Catholic and Christian faith. And he received his PhD in molecular and cell biology from the University of California at Berkeley, and earned a master's of science in cell and molecular biology from the Catholic University of America. And he also holds a bachelor's degree in English from the Catholic University of America. So great stuff. Always excited, especially to hear, and have guests who are, some of the research projects at least are, focused on curing diseases or, things that really can have an actual kind of hands-on impact. Sometimes when we talk to astronomers, it's kind of, for people, it's not as a close of a connection, and you talk about cosmology as to, hey, this actually is stuff that can help, people right now and today. So love talking about that, and it's kind of near and dear to our hearts at Purpose Nation. So Professor Kuebler, just if you could give us a little bit of an overview of a few of the kind of main high-level projects that you're involved with.
Yeah, so for years I had worked on looking at seizure disorders and looking at the effect that diet has on that. There's a lot of people that don't respond to current treatments, and there's a whole range of different sort of causes of epilepsy, many of which aren't really known. So treatments that work for certain people don't work for others, but we found certain diets seem to, particularly diets that are rich in fat, tend to reduce seizures. And we have an animal model. That's where I am. Every year I get a little slower, so this one gets a little further in front of me, but that's good.
I think you probably do a good number of kilometers out there on the road. So I respect that a lot, and that's awesome. So, and it's great that it also ties into your background, which I'd like to just kind of give a quick background anyway. It's kind of hard because you've got a lot going on there, but Professor Kuebler is a professor of biology and chair of the biology department at Franciscan University of Steubenville, which is a Catholic university. Seems like a great school. He teaches evolutionary biology, cell biology, human physiology, and as he just touched on there, his research revolves around a couple of areas, regenerative medicine and knee osteoarthritis, which I didn't realize it affects this many people, but 27 million adults in the U.S. are affected by this. And so he can...
It's relatively common,
Yeah, I had no idea. Yeah. He conducts research also on seizure disorders faced by millions of people as well, including people with epilepsy. And so he's written important papers on these subjects. He's also the co-author of a book called The Evolution Controversy, A Survey of Competing Theories. It's kind of a book that looks at the different theories of evolutionary thought, and it's a great book, and we'll definitely have a link to that on the podcast. And he's been published many times in a lot of popular articles on science and...
the fluid that's in the knee. So if you take the synovial fluid out of a healthy knee and compare it to the synovial fluid for someone that has osteoarthritis, those are two really different environments. So if we're putting stem cells into this sort of nasty environment where you have this inflammation or osteoarthritis fluid, how well do the cells do, and what supplements do you have to give them to have the cells, thrive in that environment to help possibly regenerate the tissue? It's a fascinating area because there's so little that's known. There's so many questions, and it's really an exploding area at the level of basic research to the level of applied research. There's just so many strains of thought out there, and trying to sort through it all is going to take decades, I think.
Yeah, it sounds like it. That's pretty amazing, and it sounds like you're part of being on the forefront of it there at Franciscan University of Steubenville. So if you can also just tell us real quick give you a chance to give a plug for your college there, because this is great stuff and pretty cutting edge research that you're involved with at a university that's also happens to be a Catholic university. So tell us about the university as well and your department there.
Yeah, our department here at Franciscan, it is an undergraduate only department, but our goal with our students is to prepare them. Most of them are looking at allied health fields, medicine, physical therapy, doctor of physical